Hey guys, welcome to the series of lecture in Semiconductor Physics. So myself Rohit, I'm an enterprise wireless engineer. So I am here to share all of my core subject knowledge to you guys. So last class we have discussed about the total energies that is possessed by an electron in a particular state or in a revolving surface or orbital. So this is what that formula or some equation that we derived. So this from this instant we directly came to an understanding that the total energy possessed by the electron will be indirectly proportional to the radius or orbital at which the electron is present. So this is what the conclusion we came. But we have directly taken a statement where the electron is present at particular orbital, but there is many theories have been there before we taking this model. So from the classical electromagnetic theory we came to know that any moving object, like for this is a nucleus that we have, so any moving electron in an orbital, it's need to radiate some energy and it will eventually fall into the nucleus. That is what the theory that the classical electromagnetic theory state. What it states is that any moving charges must radiate energy, must radiate the energy since electron is moving around the nucleus, it should radiate the energy. So this is what the theory that the classical electromagnetic thing says to us. Radiates the energy of electron. Energy of electron. Okay, so this is what the theory that they have. So eventually what will happen? The ET will decrease. So if ET decreases, then R will also not terminatorily need to decrease, because that what the assumption that they have is that the electron will eventually fall into nucleus, then the orbital or which the electron present will also eventually decreases. So that is what the thing they have. Then at last what will happen? Electron will fall in nucleus. Electron will fall in nucleus. So this is the traditional theory that many people believed. So after this theory, we know that if it is losses its property, then fall into the nucleus, then the element or substance will not be stable. Then it did not withstand. So after that, we clearly came to know that this theory is wrong. So after that, the scientist Bohr came and he proposed three laws, not single laws. Three laws he proposed. Three basic fundamental laws. Three things. Three basic fundamental laws. Three basic laws. The first one is that electron does not possess all the energy. Means the ET we have, right? So that is there indirectly resembling. The ET we have is does not possessed by the electron. Rather, it possesses certain set of energy level. So what they are recommending us to say is that ET is not a standard quantity of energy which possessed by the electron. Instead of that, there will be some set of energy level. We know that shell MP, SP, M, those shells we know that. So that is what indirectly they are saying. So this is the nucleus we have. So electron can be present here. So anywhere it can go to any extent. So that is what they are saying. If energy is there, if electron is here, then based on the presence of electron in which is thing, the energy will be presented. So that is what they are saying as the energy levels, not the energy possessed by electron. So this is the first theory that Bohr is stating. So from the second theory, what he is saying is that when we know that the electron is present here, here or anywhere. So what will happen if the electron from here is going here, like the transition, if it is gained some energy and goes to E2. Let's take this as E1 and this as E2. So how this will happen and what will happen? This is the thing that we are having. So first what happening is some gaining some energy and it going to E2 state. After that what happening? It's again coming back. So in this instant what will happen, and then in this instant what will happen? So in this instant the electron is gaining some energy and it possessing some other energy but moving into another state. This is one thing. Then again if the electron is falling back to the same state, the net energy transition will be radiated. So that is what the another one equation that is indirectly saying, E is equal to hc divided by nu. So this is what the formula that it's saying, Hc divided by lambda, which is the equation that it is suggesting us whenever there is a transition of electron from one energy state to another energy state. So this is resembled in this energy equation, that E is equal to Hc divided by lambda. So even we can find out the wavelength at which the energy is radiating. So that will be given as Hc divided by E. So here what we can do, that Hc divided by the net change in energy, E2 minus E1. So this energy change also we can be simplifying. So if that is happening, then Hc, which lambda, which is equal to Hc divided by del E. So this is the another one equation that we are getting, the lambda or the wavelength at which the energy is radiated when the electron undergoes the transition of this much energy. So this is the another one theory that we have. Here H is a Planck's constant, so its value which will be 6.626 into 10 power minus 34 joule second. Then c is the speed of light, which will be 3 into 10 power 8 ms per minus 1. Then 1 eV, which is electron volt, which is equal to 1.6 into 10 to the power minus 19 joule. From this we can clearly able to see that joule is a larger quantity and EV is the smaller quantity. So we our last class itself I said, so joule is a larger quantity. So we can't make that much energy, then it will be 0.000 some kind of numerical value. So in order to reduce that thing, we are used to the another one conversion to formula or standard of unit, that is 1 EV. So, okay, so this is what the conversion we used to follow for converting from one thing to one joule to EV. Then the third one what Bohr said is that while moving in these states, like n or any shell, first shell, second shell, third shell, or moving in these states, the angular momentum of electron must be quantized, means that will be quantized, and that will be integer multiple of n divided by 2 pi. So there is another one assumption or indirect physical significance we will be coming to. The angular momentum formula will be mvr. This is mvr. So mvr, which will be quantized and conversed, so integral multiple of n divided by n into h divided by 2 pi. Here n is equal to 1, 2, 3 or anything, that is integer multiple. So we have gained another one equation. So we already know another one equation from the energy possessed by kinetic energy and potential energy. So from that one we can be relating these two equations and we can able to find out another one unknown quantity. So what quantity we can find is the R is the unknown quantity that we can get. From this equation, let's take R. R will be E square 4 pi epsilon naught m v square. Here this is R square. So this will be mv square. So this is some R quantity that we are getting. This mv is another one dependent quantity, right? So that thing we can use this Bohr's third law. So when we substitute this into here, like how we can do is that mv square, which will be equal to n square. Let's take this is a whole square. mv the whole square is equal to n square h square divided by 4 pi square r square. So this is another one equation that we are having. So we are going to substitute here. So for this what we have to do, we have to multiply and divide by m. So in this next page, let me state it. So yeah, when we multiply and divide by m, then we will be able to substitute the mv square formula in this equation. So me square, which is equal to 4 pi epsilon naught n square h square divided by 4 pi square r square. So after simplifying this, we will be getting into this denominator term will go to top. So which will be 4 pi epsilon naught n square h square. Okay, so there is many fundamental terms that we can cancel. This is h and here there is ne. So after substituting everything and cancelling, we will be getting into another one formula which can be written here, like r, which is equal to, from here itself let's substitute, which will be epsilon naught n square h square. So here we are making this r, we are here, and we are moving these other terms into next term. So it will be epsilon naught n square h square divided by m e square pi. So we will be getting into the final equation of epsilon naught n square h square divided by pi m e square. So n can be equal to 1 comma 2 comma 3, anything like an integer value. So this is the radius of the orbital at any state. Depending on the n, we will be able to find out the radius of the energy present orbital. So we can, another one thing, we can directly substitute the r in ET. So if we substitute, then E square divided by 8 pi epsilon naught r. This is the energy formula we already derived. So if we substitute r here, then what we will be getting here is that I'm directly writing the end result. You can take this as homework and you can substitute it. So this will be the equation that we will be getting. So this is the energy equation. So we even we can simplify this one. Like what we can do is that ET, which will be equal to minus m e power 4 divided by 8 epsilon naught h square. Just I am removing this n square outside because this is to indicate the number of state at which it's present. So now what we can do, we can substitute the mass of the electron. M is equal to 9.1 into 10 power minus 31 kg, and all the other epsilon naught, which is equal to 8.854 into 10 power minus 12 Fermi divided by meter. So similar to that, all the thing we can substitute, and we will be getting this final numerical value of minus 13.6 into n square EV. We have to note the unit EV. So we have substituted all the thing and we are getting. So we know that this is the energy possessed by the electron. We already discussed, right? So just we are substituting the standard values and we are getting. Here the n is equal to 1, 2, 3 and anything. So this is how this will give the energy of the particular electron at different levels of shells, or we can say that energy levels or anything. So this is what the final formula that we will be getting. So let me summarize what we have to learn today. So in the beginning we have just gone through what we studied in the last or what we done in the last class. Like the energy will be indirectly proportional to the radius. Then the classical electromagnetic theory states that any moving charge must radiate the energy, then eventually the electron must fall into the nucleus. That is the classical electromagnetic theory states us. Then the Bohr scientists came and gave the three laws that the electron does not possess any energy, rather it possesses certain set of energies. Then the second law states that the net transition in energy will be radiated in this particular wavelength. Then third law states that the angular momentum will be conserved and that will be quantized an integer multiple of h divided by 2 pi. So these all are the three statements we gave, and from the three statement and energy possessed by the electron, we able to calculate the net energy possessed by the electron or at different energy levels. So that will be ET is equal to minus 13.6 divided by n square EV. So I hope this is very clear to you. So if you guys have any doubts, please ping in the comment section. I will for sure will clear your doubt. Thank you. Stay tuned for next lecture. Share, subscribe and like the videos. Thank you.